Hi, I'm Andrew. Today I would like to teach you how to use the graph to write an equation for the rational function. Now, we're going to focus on two things, intercepts and asymptotes. All right, that's going to help us create the function. So remember there are two types of intercepts. There's going to be x-intercepts and y-intercepts, and x-intercepts are just where the function crosses the x-axis. In other words, the x value of where it crosses the x-axis. So we have one x-intercept over here at -4, so I can write -4, 0, right, because that's the coordinate of that point. And I can also do the same thing over here. So there's two x-intercepts at 1, 0 as well. Then looking at the y-intercepts, we realize that it crosses the function, crosses the y-axis at one point, and there should only be one if this is a function, otherwise it wouldn't pass the vertical line test. So we have a y-intercept there at 1, and we would write it 0, 1, because the x value of all the y-intercepts are 0, and then the y value is just going to be wherever it crosses the y-axis. Next thing we're going to do is focus on the asymptotes. Now it turns out that we have only one vertical asymptote here to worry about, and that sounds great to me. So it looks like we have a vertical asymptote at -2. Remember, all vertical lines have x equaling some constant. All right, the y values change as you go up and go down, but the x doesn't. It stays the same, and that's why we write vertical lines being x equals something. So we have one vertical asymptote here, and we'll say it's going to be at x is equal to -2. And that's really it. There's also probably some slant asymptote. You might have noticed it in here. That doesn't really help us, though, with anything. All right, we don't need it, thank goodness. Otherwise, that would be kind of a little ridiculous. Imagine trying to do that. What's the equation of that line? You got me. So good thing we don't have to worry about it. Anyway, so let's get down to the rational function. So remember, a rational function is going to be something where you have a polynomial function in the numerator. You can call it g of x, divided by then a polynomial function in the denominator, call it h of x, some different function. All right. Now it turns out that the vertical asymptotes, you're always going to consider them as values that are going to be utilized in the denominator. All right. Remember, a vertical asymptote is a value that represents a value of x that the function just can't obtain. It never is -2. Never, ever, right? X, we cannot plug -2 into the function. Otherwise, it does something wacky. All right, it does something wacky. So what's so wacky about it? Well, it causes the denominator to go to 0. So now my question to you is, what expression must I write in here such that if I plug -2 into it, let's call that here, creates 0? Well, if I add 2 to it, right? I mean, -2 plus 2, what's that? 0. Yeah? So that's the idea. That's all we got to do. Okay? That's all we got to do. And that's what we're going to do. So, but instead of writing -2 there, you're just simply going to write x. Okay? X plus 2. So hopefully that makes sense. And that's the vertical asymptote. If you had two, if you had another one, you'd write another factor that multiplied, but we don't have to worry about that here. Turns out the x-intercepts are going to be the same thing. Remember, this is telling us that when x is -4, the function's value is 0. Now, the only way this fraction will go to 0 is if the numerator is 0. So it turns out it's a very similar technique as we used in the denominator here, we can use in the numerator. So basically, when x is 4, okay, we want this term to become 0. So what do? Well, you add 4 to it, right? So in other words, it's simply going to be x plus 4. And then the other term is going to be, you guessed it, x minus 1. You basically might have noticed now a pattern in that whatever the sign is, you're just going to switch it right and add it to x. That's all. Now, last but not least, the y-intercept. Please always save that for the end. So what you have to do now is I'm going to write in a symbol here, c, for coefficient or for constant. All right. And the goal here of using the y-intercept now is going to be to take your y value of 1, plug it in for the function's value, because that's basically the y value. And everywhere you have your x, you're going to plug in a 0. Or you're going to plug in a 0. So when we do that now, we're going to get something like 1 equaling c times now 0 plus 4, 0 minus 1, all over then 0 plus 2. Okay, great. Simplify this now, and we're going to get then -1, oh no, -4, whoops, over 2, which is going to work down to -2. All right, and how do you solve this for c? Because that's really what we need. Hey, how do you solve it for c? Huh? So you're going to divide by -2. That was my best impersonation of New York, maybe? I'm from New York, and I can't even do it. Coffee. Yeah, there you go. Coffee. You want some coffee? Huh? Coffee. Okay, enough of that. So C. You're going to plug it in now. So it's negative 1 over 2, or 1 over negative 2. It doesn't really matter, right? And that's it. I mean, that's the function. That's all there is to it, ladies and gentlemen. Now, you can clean up the top by foiling it, okay? Remember, that's the first times the outer times the inner times the last, the FOIL. You can simply shortcut it by adding these two together, which would be a positive 3, shove an x on it, and then multiply those, which would be a negative 4. Okay? So remember I said positive 3, negative 4, right? Positive 3, negative 4. So plus 3x minus 4. That's a squared. And that's it. That's all there is. Now you can always check yourself. Plug it into your calculator. Clear out anything that's in it. Now do negative 1/2, all right, times. And I'm going to open the parentheses. So x squared plus 3x. You need parentheses here because you have to tell the calculator that you want to take that whole numerator and divide it by the whole denominator. All right, x plus 2. You might not need to write the parenthesis here in your answer, but you definitely need it in the calculator. Hit graph. Look at that. Does that not look exactly like the graph we have on the page? Well, close, right? You might say, well, yeah, I don't know, man, it doesn't look quite like it. I wouldn't disagree with you. All right, this one looks a little flatter, but the reason is because they incremented this by 2 all the time. All right, and my graph over here is only incremented by 1. All right, so that's why it looks a little like more elongated, but it is the same thing. Thank you very much for tuning in. I really do appreciate it. If you can like, subscribe, maybe even tell some of your classmates. We'd appreciate it so very much. Thank you for all the support you've given us over the years. We look forward every day to keeping you guys entertained and producing more content. And check out our channel because we got thousands of videos, not only here in math, but chemistry, physics as well. And we got a lot of stuff coming. Stay tuned.